when I look at a polynomial subtraction problem, I don't look at it necessarily as subtraction, but instead, because of these parentheses I have, I think about it as a distribution problem first. So I look at what am I distributing to this first set of parentheses, and it's just a positive 1, which is going to work out very nicely. And I look at the second set of parentheses, and what am I distributing here? Well, I'm distributing a negative 1 to both of my pieces. So if I can remember this fact, that subtracting polynomials is really just distributing a negative 1, it's going to make life a lot easier. Because when I do this distribution, I get 4x minus 3, because I multiplied everything by positive 1. And then this becomes minus 6x minus 2. I've gotten rid of the parentheses because I distributed, and now all I have to do is combine like terms. So put the x's with the x's, and put my numbers with my numbers. So if I take 4x minus 6x, that gives me negative 2x, and I like to put that first so I'm in standard form. And negative 3 minus 2 is negative 5. So I've successfully completed the polynomial subtraction and gotten this binomial right here as my answer. I can extend this type of thinking to problems that look a lot more complicated, but really aren't that bad. Here we have a mixture of addition and subtraction, but I want to approach it in terms of distribution. I distribute a negative 1 if I see a negative sign in between. And in any other case, I'm just distributing a positive 1, so nothing changes. So let me go ahead and distribute and rewrite these terms. So I have 3x squared plus 2x minus 1, nothing changed, minus 6x squared plus 4x minus 2. Notice how it changes all of my signs. And lastly, minus 8x squared plus 6x minus 15. And at this point, it's just a matching game, looking for like terms. I have x squareds, and x squareds. So whenever I go ahead and put 3 and negative 6 and negative 8 together, I get negative 11 x squareds. Then take a step down to the x's, so my answer ends up in standard form. There's 2x's there, 4x's there, and 6x's there. So I end up having positive 12x. Again, notice how I don't change the exponents when I'm adding and subtracting. Last but not least, let's put the constant terms together. A negative 1, a negative 2, and a negative 15 is going to give me a constant term of negative 18. So when I add and subtract these different trinomials, I end up with the quadratic trinomial negative 11x squared plus 12x minus 18. There's nothing more I can do to simplify. So when I'm subtracting polynomials, I'm just distributing a negative to 1 and then combining like terms.